Hey guys, just wanted to try another method of this video for conversions. For today, for the warm-up, I want to go through the conversion questions again. And I've got this new thing that I'm using. It's a whiteboard that I can use my computer screen for and then record at the same time. So I'm hoping this works. I'm going to give it a shot. All right, so looking at your warm-up, on one of those conversion questions, they asked about converting time. And so they had 4,000 and, I'm going to just get my pencil here. They had 4,320 minutes, and they wanted to convert that into days. And so I want to review something that we had done a little bit earlier back in school, which I used this little format where we put in some different units that were equivalent, and we were able to move from one unit of time or one unit of measurement into another unit of measurement. So we're starting out here with 4,320 minutes. And I'm going to put that in my first little block up at the top. This is sort of like fractions, like we're multiplying fractions together, equivalent fractions. So we've got 4,320 minutes. You can imagine that over 1, but for right now I'm just going to leave it like that. And we want to convert that into days. So I want to find an equivalent value using minutes that we can get to larger units of time. So I know that minutes are a small piece of hours. So if I have 1 hour, that is equivalent to 60 minutes. There are 60 minutes in 1 hour. And I'm going to write it like this. 1 hour and 60 minutes are equivalent. So it's almost like writing an equivalent fraction, or a fraction that, that equals 1, because it's the same value. So it's like I'm taking the 1 hour and 60 minutes and multiplying it by 4,320 minutes. But it doesn't really change anything because 1 hour and 60 minutes are equivalent to one another. So it's like we're multiplying by 1. Okay, so what we can do here is see that those minutes are going to cancel out. We have 1 in the numerator, 1 in the denominator. And we're going to then change those minutes into hours. But hours aren't what I want. I want days. So we need to then move from hours into days. And I know, and so do you, that there are 24 hours in 1 day. So again, I'm writing a fraction here that really equals 1. It's like we're multiplying by 1 each time. And what we'll see here is that minutes will cancel, hours will cancel, and we've now taken 4,320 minutes and converted it into days. So the way we do that is to just multiply across the numerator, which 4,320 times 1 is just 4,320. That's pretty easy. Divided by 60 times 24, which I did this out earlier. I think it was 1440, if I recall. You can do that on your own just in case I'm messing that up. I'm pretty sure it was 1440. And then all you need to do is divide 4,320 by 1,440. And we can just do this, by the way, guys. That makes it a little bit easier. Cancel off those zeros. And if you divide, you're going to get 3 days. So what that tells us then is that 4,320 minutes is equivalent to 3 days. So this is one way of converting time and just kind of setting it up with that, call it dimensional analysis, but it's a fancy way of just saying multiplying by equivalent fractions, or by fractions that are equal to 1. All right, so that's the first one. My little eraser doesn't do quite as good a job as on the other thing. That's okay. All right, I'm going to erase this a little bit here, and I want to move on to converting temperature. So we talked about this back in school as well, and we even used this formula. They give us 2 formulas. The first one converts Fahrenheit to Celsius, and the other one converts Celsius to Fahrenheit. And the question that they're asking us is, at least in one of the questions, is let's just change 9. Let me go back to my pen. 9 degrees Celsius into its equivalent Fahrenheit value. All right, so they're very nice to us. They give us the equations. It's pretty easy to do. We just have to substitute in. So because we want to know what this equals in Fahrenheit, we need to use the equation that says F equals. So you want to figure out, okay, so you're given Celsius, you need to find out Fahrenheit. So you want to find the one where F is solved for itself. So it's isolated. So the one that looks like would be this equation. Fahrenheit equals 9/5 C plus 32. Okay, and in this equation, we can substitute in the 9 degrees for Celsius and solve to find Fahrenheit. So that's what we're going to do. We're going to put in 9 for C and go from there. So now, think about this as fractions again. When we're multiplying fractions, you multiply the numerators by themselves and the denominators by themselves. So this would be 81/5 plus 32. And the direction said to round to the nearest tenth, which tells me we're probably going to get a decimal, and we are. 81/5 is equal to 16.2 as a decimal. If you had divided, remember that divide would be 5 into 81. Goes in 1 time. We've got 31 left. Goes in 6 times. Oh, come back. Come back, little screeny thing. Oh well, that's okay. Goes in 6 times. That's going to be 30. And we subtract. 5 goes into 10. It's going to be 0.2. All right. So 16.2 is the decimal equivalent of 81/5. So then we just put in Fahrenheit is equal to 16.2 plus 32. And so the temperature in Fahrenheit is 48.2 degrees. Whoops, my little degrees are a little big there, but that's okay. It's not 20, it's degrees. So what that tells us is that 9 degrees Celsius is equal to 48.2 degrees Fahrenheit, which is interesting because 9 degrees in Fahrenheit is very, very cold. It's below freezing. But in Celsius, it's not that bad. I mean, it's 48 degrees. We're not talking balmy or anything, but it's not freezing at all, which is kind of interesting. All right, so those are 2 of the conversion methods, conversion questions. And I just wanted to kind of go through some of those with you. The other one that you have, I just want to do one little quick review on that one. Get my eraser back up again. All right. Oh, that's not the eraser. Come on now. There we go. All right, so the other one, the only thing I really want to talk about with that one is the prefixes. So the last conversion section on your warm-up was a little tricky in that they had the prefixes listed on the side, but they didn't talk about the base units. And so I want to just review that. It's been a long time probably since you've done those sorts of questions. I just kind of want to review a little bit. So on the side of your warm-up, they had things like M equals 1,000. Is that right? 100? 1,000th maybe. They had K equals 1,000. I'm trying to remember now, guys. They had C equals 100. D equals 10. And what they're trying to do there is explain the prefixes that go along with the base unit. So the base units of metric would be like G is for grams, M, which kind of matches up to the other M, which I don't like, is for meters. They've got L for liters. Trying to think of the other one that was out there. That might have been it. And these are the base units. So what they're saying here is that if you've got km, that's like having 1,000 meters. All right, a kilometer is like 1,000 meters. if you have like a CL, that's like having 100 liters. And let's say you have a DG, all right, a decagram. It's like having 10 grams. So those prefixes are kind of what they had listed off there. And I wanted to kind of explain what they meant, because some of those look very similar to the base unit, like M matches up to M for meters. So if they're saying they want to have you convert liters into kiloliters, you just take the liters and you multiply it by 1,000. If they're asking you to convert grams into decagrams, you would just multiply by 10. If they want you to go kind of backwards, maybe you're at kilometers and they want you to go to meters, you would just divide it by 1,000. So it just depends on which direction you're going. And I just want to kind of explain that a little bit, because the prefixes were a little bit tricky, a little hard to understand there. All right, well, this was my first time trying out a whiteboard app with a Screencast-O-Matic, and I did it without even brushing my hair today, so apologies right there. I hope you guys are doing well. Call me if you need anything. And today, which is April 30th, at 3 o'clock, I'm going to have a Zoom. It's on the, I think I put it up there already, onto the lesson plan. So if you have questions, I'll go through these with you. I'll go through anything dealing with slope or y-intercept, parallel, perpendicular lines. I can do all of that, anything that you need. All right, I hope you have a great day. Miss you guys, and I will talk with you later.